If your embeddings work, but miss the important domain stuff, you need hard negatives. We'll fine-tune a sentence transformer so jargon queries finally retrieve the right docs. You notice searches returning plausible but wrong answers. That usually means the embedding space learned general semantics but missed domain signals. After this video, you will know how to expose that failure, mine strong negatives that cause confusion, and fine-tune a sentence transformer so jargon and acronyms resolve correctly in search. I'm Professor Pi, teaching search and IR from basics to advanced with simple concepts-first Python that helps you solve bigger real-world problems. Domain search fine-tuning targets the gap between general embeddings and domain needs. People reach for it when a model returns semantically related but domain incorrect documents. Success looks like the top result matching your domain intent, not just a similar sentence. This method sits in the retrieval pipeline after initial indexing and before production serving. It is a surgical fix. You add a small fine-tuning step to reorient the embedding space around confusing cases. Intuitively, we want the model to pull true domain matches closer and push confusing near misses away. A common example is an acronym that means different things in different fields. A baseline model may cluster both senses together. Mining hard negatives means we find the closest wrong neighbor and teach the model to separate it. The model then learns to respect domain cues that general training missed. We will build a short pipeline. First, we run a baseline retrieval to see acronym ambiguity. Then we mine hard negatives by picking the strongest non-gold neighbor. Next, we fine-tune the sentence transformer with TripletLoss. Then, we measure the margin change and report hits at 1. That sequence keeps the code simple and the signal strong right before we look at training details. Now we will run a baseline retrieval to see where ambiguity shows up. This snippet runs a SentenceTransformers baseline retrieval to expose acronym ambiguity. This snippet encodes a set of queries and a set of documents with a pre-trained SentenceTransformers model, then computes pairwise cosine similarity to rank documents per query. The core idea is to observe which document appears first for ambiguous queries. Key lines load the model, call encode on queries and on documents, and compute cosine similarity to get a highest scoring neighbor. The important parameter here is the number of top results to inspect. Choosing top 5 gives a clearer picture of near misses. The output highlights cases where the top neighbor is semantically close but wrong in domain, which is the failure we will fix. Next, we will mine the strongest wrong neighbor for each query. This snippet mines a hard negative by picking the strongest non-gold neighbor. This snippet walks the ranked list produced earlier and selects the highest scoring document that is not the labeled positive. The idea is to pick negatives that the baseline finds most confusing, not random negatives. Key steps include checking identity against the ground truth, skipping true positives, and logging the chosen negative per query. That chosen negative becomes the hard negative in training triples. The hardness parameter is implicit in how strong the chosen neighbor is. If you pick 2 easy negatives, the model barely learns. If you always pick the single top non-gold, you get the hardest consistent signal, but you must watch for label noise, where a chosen negative is actually a second valid match. Now we will fine-tune the encoder to push positives closer than these hard negatives. This snippet fine-tunes SentenceTransformers with TripletLoss using a mined hard negative. This snippet constructs training triples of anchor query, positive document, and the mined hard negative, then feeds them into a SentenceTransformers trainer configured with TripletLoss. which enforces that the positive is closer than the negative by a margin. The main lines build a data set of triples, create a data loader, and run the trainer for a few epochs. Two knobs matter most for behavior. The margin controls how much closer the positive must be compared to the negative. A larger margin forces stronger separation, but can slow convergence. The batch size and number of epochs set how many hard examples the model sees and influence stability. After training, we will quantify how much separation improved between positive and hard negative. This snippet measures the post-tuning margin between the positive and the hard negative. This snippet recomputes embeddings for the same triples, measures cosine similarity of anchor to positive and anchor to the hard negative, and then computes the difference as a margin. The core idea is that an increased average margin shows the model learned to prefer the gold document over the confusing neighbor. Key values reported are the mean positive similarity, mean negative similarity, and their mean difference. If the mean margin grows and fewer margins are negative, that is a clear sign of improved discrimination. You can also inspect per query margins to find remaining failure cases. Finally, we will report a straightforward retrieval accuracy metric to see end-to-end gains. This snippet computes hits at 1 to show the tuned model retrieves domain-relevant results. This snippet runs the tuned SentenceTransformers model over queries and documents, ranks candidates by cosine similarity, and computes the fraction of queries where the top-ranked document is the labeled correct document, which is hits at 1. The metric directly answers whether tuning moved the right document to the first position. Key observations compare hits at 1 before and after tuning. An increase means your fine-tuning and hard negative mining translated into a user-visible improvement. If hits at 1 does not move, inspect mined negatives and margin behavior for noisy labels or insufficient training. In a real system, this toy pipeline maps to a retraining job. The baseline retrieval uses your current production index. Hard negative mining can run on a sampled validation set. Fine-tuning updates the encoder weights and you replace embeddings and reindex. The margin and hits at 1 drive a release decision. Recap what it is. Fine-tuning a sentence transformer with hard negatives to fix domain confusion. When to use it. When general embeddings return semantically plausible but domain-wrong results. One caveat: overly hard negatives or noisy labels can teach the model the wrong distinctions, so monitor margins and per-query failures. Next step, tune the triplet loss margin and try using multiple hard negatives per anchor to see if that yields a steadier margin increase. If short practical IR helps, subscribe and watch the IR videos.